Hey, hi, Rajan this side. Welcome to my YouTube channel. So today we will solve all the four problems asked in today's LeetCode Weekly Contest for System. So let's start with the first problem. So the first problem says that you are given an integer array nums and the length is divisible by 3. You want to make the array empty in certain number of steps, and in each step what you can do, you can select any three element from the array. You can compute the median and remove all these three selected elements from the array, right? And we know the definition of median, so that is fine. And you have to return the maximum possible sum of the medians computed from the selected elements. All right? For example, let's say 213 213. So the max possible sum of the medians is 5. Let's see how. So in the first step, it removes index 2 4 and 5, means 2 4 and 5, so 1 3 and 3. So the median of 1 3 3 and 3 is 3, so the median of here is 3. Now index, so once you remove 1 3 and 3, now what is left? 2 2 and 1, right? 2 2 and 1 is left, and the median of 2 2 and 1 is 2. So the total sum, maximum sum possible is 5, right? So yeah, let's see how we can approach this problem. This is pretty much an intuition problem. So in the first test case you were given 213 213, right? And the second test case you were given 1 1 10 10 10 10. So what I'll do, I'll first sort the given array, right? So the array become 1 1 2 2 3 3. Now I claim that to get the maximum possible sum of medians, what I will do, I will choose for one element from the start and two element from the end. So once you do that, once you pick 1 3 3, so your median would be 3 plus. Now what is left is 1 2 2. Now if you choose 1 2 2, now your median would be 2. So the answer is 5. Now coming to the second test case, this is already sorted, so no need to sort it again. So uh, so once you pick one element from the start and two element from the end, your median would be 10 plus. Now once you remove 1 10 10, what is left? 1 10 10 again. Now pick one element from the start and two element from the end. Now what is median? Median is 10. So your sum of median is 20, which is your answer. Now the reason why this this is correct, because we are always picking the best value, right? Because what we are doing, see, once you sort the array, your max element would be present at the end, right? At the end point of the array. Then why not pick the maximum, like why not pick the median from the end? And to pick the median from end, you have to take two elements from here. You have to take two elements from the end. Otherwise, let's say you are taking two elements from the start and one element from the end, then your median would come in this half, in the left half, which is anyway, since you are already sorted the array, these numbers are less than the last numbers, right? So that is why we are picking two elements from the end, not two elements from the start. And like, so if you're choosing random numbers, then it would anyway not help you. So, and yeah, so this is the solution why we are picking two elements from the end, not two elements from the start, because we want to pick the median from the end point of the array, because these are the maximum numbers once you sort it, right? So yeah, this is the explanation part. Now let's look at the code. This is the code of first problem. So initially I first sorted the array, and this is your answer, and this is your size, and this is I and j. I is the left index and j is the right index of the selected elements. Now if you have I and j, I'm saying that your current selected sum would be, since the array is sorted, so as I mentioned, we have to pick one element from the start and two elements from the end, right? So if you have I and j, your selected element should be I at index I, and so this is the one element from the start and two element from the end. So the second element would be at index j minus 1, the third element would be at index j, right? So that's why I have a while loop here. If I is less than j minus 1, I is less than j minus 1, if that is true, your answer would be nums of j minus 1. Nums of j minus 1 means the second element from the selected elements, right? And once you pick this element, this median, now your I would be incremented by 1, but j would be decremented by 2, right? Because we have picked two elements from the end and one element from the start. And and at the end return your answer. So yeah, this is the code of first problem. Now let's look at the second problem. Second problem asked in today's contest. So it says you are given a string S consists of uppercase English letters, and you can insert at most one uppercase English letters at any position, right? And at the end you have to return the maximum number of LCT subsequence that can be formed in the resulting string after at most one insertion, right? And we know what is the definition of subsequent. So this is really interesting problem. Let's see how we can approach it. I'll keep the explanation pretty simple. So we have to find out the maximum number of LCT subsequence after doing at most one operation, right? So first, so I'll solve it into two parts. So the first part would take care of the case when you are not doing any insertion, right? In that case your answer would be the number of original LCT present in the like in the given string, right? Now the second part, when you are doing one operation, it means that you can either insert L or C or T, right? C, you can insert any uppercase alphabet, but it won't help you, right? We have to find out the maximum number of LCT subsequence. So it would always be better to either insert L, C and T. Now let's come to L. Tell me which position would be the most suitable to insert L. If you are inserting L, means that you are hoping to get maximum number of LCT. What I will say, I will always insert L at the beginning of the string. Let's say this is your given string L, M, C, T, right? This is your given string L, M, C, T. What I am doing, if you are planning to insert L, always insert at the beginning to get the maximum number of LCT, right? Now similarly for T, if you are planning to insert T, I would say the most suitable position would be at the end. Always insert T at the end, right? So given string is LMCT, right? If you are planning to insert T, always insert at the end in order to get the maximum number of LCT subsequent. Now to insert C, what I'll be doing, I'll go through all the position from 0 to n minus 1, and I'll choose the maximum, I mean the place where you can get the maximum LCT. And now for now let's say you are at index I and you are planning to insert C here, right? How many LCT you can get? The number of LCT would be the number of L present before C and the number of T present before after C, and just multiply of L into T. So these many number of LCT you can get if you are planning to insert C here, right? And so we will iterate through all the position from 0 to n minus 1, and we will pick the maximum value at any index I where you can get the maximum number of LCT. And the number of LCT at index I would be number of L before C into number of T after C, right? So yeah, this is the explanation part. So we have covered all the cases. So the first case, when you're not inserting any alphabet. The second case, if you are inserting any alphabet, consider all three cases. If you are planning to insert L, if you are planning to insert C, and if you are planning to insert T, right? So yeah, let's see how we can write code for it. This is the code of second problem. This code is written exactly how I've explained in the explanation part, so I would highly recommend to check out explanation part first, and then you can look at the code, right? So this is your given string S, this is your size. So initially I have created a suffix T array, which essentially means suffix T of I equals to number of T present from index I till n minus 1, right? And this is your I. So this is how I calculated suffix T array. And now we are jumping over to the two parts which I have explained in the explanation. First part is that when you are not doing any insertion, right? If you are not doing any insertion, we have to find out the number of LCT present in the original array, right? and to find the LCT we would need number of L present and number of LC present information, right? So here we are iterating from left to right. So let's say your correct index, like the character at correct index is L, then your L would be incremented by 1. And if your character at correct index is C, your LCT would be your LCT would be number of L present before this index into number of T present after this index, right? So LCT plus equal to L into suffix T of I plus 1, and your number of LC would be incremented by L, right? Because your current character is C, so LC plus equals to L. So this is how we calculated LCT and LC. Now we came to the second part. The second part was when you are planning to insert L, C or T, right? So let's look at let's try to find out. So see, now in the second part, the first case was when we are planning to insert L, right? So as I mentioned, L would, the base suitable place to insert L is the beginning, right? So for that we have to find out the number of CT present, right? Because if you know number of CT, we can insert number of L at the beginning, and you can create LCT. So let's see how we can create how we can calculate C and CT. So we will again iterate from I is equal to 0 to n minus 1. If your current index is C, your C is incremented by 1, and if you encounter T, your CT is incremented by C, CT plus equals to C, right? And this is the case when we are trying to find LCT by inserting C, right? So as I mentioned, to insert C, we have to iterate through all the position from index 0 to n minus 1, right? So that's what we are doing exactly here. Let's say you iterate from index I equals to 0 to n minus 1 from left to right. If you encountered C, your L is incremented by 1. Now we are planning to insert C here, right? To insert C here, what information you need? You need how many L's present till index I and how many number of T present after this index. And then if you know these two information, we can just simply insert C here to form LCT. So your maximum would be a maximum comma number of L present till index I into number of suffix T, the number of T present till index I on the right side. And this is how we calculated mx. So mx is essentially, till here your mx would be the number of LCT which you can get after inserting C. But wait, we have to consider two cases, right? We have to consider essentially three cases. If you are planning to insert in the second part, we have to consider three cases. If you are planning to insert L or C or T, this is how we get the max value if you are planning to insert C. Now consider two cases. The number of L, how many number of LCT which you can get if you insert L at the beginning, that would be number of CT. If you know the number of CT, just insert L at the beginning. So now I updated here max is maximum of mx comma ct comma lc. This is the case. LC is the case when you are planning to insert T at the end. CT is the case when you are planning to insert L at the beginning of the string, right? And at the end your answer would be LCT. LCT is the case when the part 1, when you are not planning to doing any insertion operation, that would be number of LCT plus maximum which you can get among these three operation if you're planning to insert L or C or T, right? LCT plus MX. So this is the code of second problem. Now let's look at the third problem. This is the third problem asked in today's contest. So it says you are given integer array nums of size n. You have to start from index 0 and you have to reach at index n minus 1. Now let's say you are at index I, so you can do one of the following operation. The first operation is that either you jump to the next index or the previous index. Now the second operation is pretty interesting. So it says if your current number is a prime number, right? Let's say the number is p, you can move to any of the index j, which is essentially not equals to the current index, such that nums of j means that the number present at the index j is divisible by p, or in other words I could say p is one of the prime divisor of that number. If that is true, you can move you can jump to the index j, and at the end you have to return the minimum number of jumps required to reach at index n minus 1, right? So yeah, let's see how we can solve this problem. In the problem, we know that if you are at index I, you can either move to index I plus 1, the next index, or you can move to index I minus 1, or if this is a prime number, if this is a prime number, right, if this is a prime number, what you can do, you can jump to any of the index j such that your nums at index j is divisible by p, right? Or in other words, I could say p is a prime divisor of that number, right? So see, to move to next index and previous index is easy, but to move to all the indices which is divisible by p, we have to kind of store some information, right? So let's see how we can store this information, right? So so this is your given array uh, from 0 to n minus 1, right? Let's say you are at index I. So what I'll be doing, I'll first calculate all the prime divisors of that number. So this is your nums of I will calculate all the prime divisors p1, p2, p3 up to pk. Let's say these are the prime divisors. What I'll be doing, I'll create a map, an order map of int comma vector of int, and for all these prime divisors I will insert this index. So this is kind of a reverse mapping, and once you calculate this information beforehand, I'll make use of it. I will go through. So see, this is essentially all j. Once you calculate all the, like, so once you insert index I to all the prime divisors, that's all we wanted here, right? We wanted to jump from I to j, which is divisible by p, and p is a prime number, right? So the first step would be calculate this information beforehand, and then we can essentially use a simple BFS here. So BFS, how we are going to implement BFS here? So initially your distance of 0 would be 0 because we are starting from the 0 itself, and now like in the standard BMS we use q, right? Q of integer, which is q, right? Then we would go in a while loop. We would pop out the first element, like the front element from the queue. Now let's say that index is I, so we would do a standard thing, right? Now we can move to the next index, previous index, or these many index. So accordingly, let's say your current index is I and your distance 50. We would go through all these three possible positions, right? I minus 1, I plus 1, and all these positions. We would check if your if so let's say that index is j. If the distance of j is greater than distance of I plus 1, right? This is one extra jump. If that is true, just update it. Just update distance of j equals to distance of I plus 1, and then insert this into the queue. Insert this into the queue. Right? Insert this into the queue. Yeah, so this is all about the explanation part. Now let's look at the code. This is the code of third problem. So you are given nums array. This is your size. I just check if your size is 1. If that is true, return 0. And in the problem statement, if you would have noticed, your number can go up to 10 to the power 6, right? So I calculated SPF array. SPF is basically your smallest prime factor for all the numbers up to 10 to the power 6. Now there are two reasons to calculate SPF. First, to check if the given number is prime number or not, and for all the prime numbers we know that SPF of I equals to I, right? Now the second reason to calculate SPF was to calculate all the prime factors. So in the prime, like in the explanation part I mentioned, we need to find all the prime factors, right? So we have to so to find all the prime factor we would again need SPF information, right? So yeah, so till here I have calculated SPF. So I have like boiled this code down into multiple chunks. The first chunk was to calculate SPF array. Now and one more thing, this is a standard implementation of SPF using Siev's algorithm. So if you don't know about Siev's algorithm, I would highly recommend to learn it from the online tutorial. It's called Sieve of Eratosthenes, and that algorithm, that Siev's algorithm, is really helpful to find prime numbers in a given range or SPF in a given range, right? So if you are not aware of this algorithm, I would highly recommend to learn it from online tutorial. So till here I calculated SPF. Now we came to the reverse mapping part, right? Here in the explanation part, I mentioned that for all the prime factor, I would be storing the index I. So this is what exactly I'm doing here. So here this is my unordered map, right? So I'm going for all the numbers like in the given array. This let's say this is my current value at index I. What I'm doing, so this is a standard implementation of finding the prime factors, right? So here what you do, this while loop essentially gives you all the prime factors. So let's say this is my prime factor. What I'm going to do, I'll just store this index at for this prime factor in the given collection, and I'm just keep on dividing it so until you get the next prime factor, right? So till here you again calculated all the prime factors, all the prime factor and the indices. Now we came to the last part using BFS. So in BFS what you do, you first create a distance array. So initially your distance of 0 equals to 0. This is your standard queue. So initially I keep this index 0 into the queue. Now I am going through all the numbers from the queue, and so there are three possibilities now. Either you move to the next index, or you move to the left index, I mean the previous index, or all the prime divisors of it, right? So that's what exactly I'm doing. I just check if your next index is within the boundary, and the distance to reach at index I plus 1 is more than distance of I plus 1, right? If that is true, just update it and keep it into the queue. Now same for previous index. If your I minus 1 is within the boundary, and if distance is more than distance of I plus 1, update it and keep it into the queue. Now the last step is to check if the number is prime number or not. To check, so let's say k is my current number, right? K is the number present at index I. I just check if the number is prime number or not, and we know that to check the prime number, like if the number is prime number or not, just check if your SPF is that number itself. So SPF of k equals to k, it means that this is a prime number. If that is true, I'm going through all the indices present in the collection, right? This is your IDX present in the collection. Oh, I'm going through all the indices present in the collection. I just check if your distance of that index is more than distance of I plus 1, right? If that is true, again update it and keep it into the queue. And here I just cleared it, because for any prime number, if you have already done all the processing, all the the exploration part or updation part, there is no need to do it again. It will be kind of a duplicate. Like for any prime number, if you've already done this process, you don't need to do it again. Just clear it from the collection. And at the end, just check if your distance of n minus 1 is already found. If that is found, just return it. Otherwise, we anyway return it from like outside of a while loop. So just return distance of n minus 1, right? So yeah, this is the code of third problem asked in today's contest. So if you find any difficulty in this code or anywhere in this tutorial, please write a comment. I'll reply to all the comments, right? Yeah. So yeah, this is all about the tutorial for the first three problem asked in today's contest. If you find it helpful, please like, subscribe to my channel. Also share it with your friends. Yeah, thanks for watching. Have a nice day.